of water quality measurements, testing. She's a researcher and she has been working with different water body in Kenya. She worked with the Kenya Water Institute. Now she's working in Nairobi Water and Wastewater Management Company. And we are privileged to really welcome her right now. And so she can maybe start her introduction herself. I can't really say much about her, so she will be able to tell us more. So over to you, Madam Pekuro.
Good evening, everyone, and welcome. I don't know if you can hear me. Am I clear now?
Yeah, we can get you 5 on 5.
Yeah, good evening, everyone, and welcome to this training on advanced water treatment technologies. I first would like to start by apologizing for not hosting this training. This was supposed to be on Saturday night. I had some power issues on my end, so I'm sorry for that. So we thought we'd have this meeting today. I hope I didn't inconvenience anyone. Yeah, so my name is Bikoro Gisamba, as Mr. Ekole has said. I am at the moment working at the Nairobi City Water and Sewerage Company in the Water Engineering Department. And I'm going to be taking you through this training on advanced water treatment technologies. So, Mr. Ekole, if you can go on with the screen.
Okay. It's great. Yeah. So I'm going to share my screen now. So I'm not. Okay. Okay, so this is what we have now. Great.
Yes, so our training today is going to be again on advanced water treatment systems and technologies. We are going to look at how we can treat our water and how our governments maybe treat our water. That is, mostly we're going to be dealing with drinking water, but I'll maybe do a slight overview of water treatment, but I'll majorly deal with drinking water. So if I go too fast, someone please just let me know that I'm too fast, because I tend to be so fast in my speech. So we'll start with an introduction. Why do we treat water? So we treat water because it contains a myriad of contaminants that are detrimental to the health of human beings and animals. If you've gone through our previous YouTube videos, I had done a training on the different constituents of water. That is, I had talked about the different chemical constituents of water and the biological constituents, which would render drinking water unsuitable for human beings. So right now, I'm dealing with how we can treat, just get to remove these contaminants from this water. That is the chemical and the biological contaminants from water. So the contaminants could include chemical elements such as fluoride, manganese, sulfides, and biological elements such as bacteria. All these need to be removed because, if you drink water with too much fluoride, you get to have the brown teeth, that is dental fluorosis. And if you drink water with, say, E. coli, you get to have waterborne diseases, cholera, bilharzia, things in that line. As I had said before, these were covered in my previous training on water quality parameters. Next slide. Yeah, so I categorize water treatment methods into two. That is physical methods and chemical methods. Next slide. So physical methods employ filtration techniques, which are aimed at removing solids of various sizes from the water. So with physical methods, wherever the water is being treated at, a membrane is used. That's why we call it physical, because a physical, like a membrane, is used. But with chemical methods, you find that we add some chemicals, or we employ some chemical, say, process in order to treat the water. But for now, we're going to deal with physical methods. Next slide. So they include the following. One of them is the use of screens. So screens filtration through the use of screens is done at the beginning of water treatment processes to remove large materials from the water. If you have visited, say, a water treatment plant at the very beginning, at literally the first step, or where, say, there's a river and the water is being abstracted, the water that is taken to the treatment plant, there's a screen that is placed there in order to just filter off the large solids. This could be rags, twigs, rocks, such that the water that is coming through is free of these big solids. So that is done in a water treatment plant. And also this is the first process in a wastewater treatment plant. They need to remove the solids because if the solids proceed on to the other stages, they might tend to ruin the equipment that are present in the wastewater treatment plant. So next slide. This is supposed to be a video, Mr. Ekole. Yeah, play. So this is a wastewater treatment plant. That's the water that is coming in. And if you twist your heads a bit, you will see the screens on there. And that is what I meant by use of screens. So that's one step that's the first step in physical treatment methods. Yeah, that's what you have on there. Those are the screens. Usually the bars are the screens. Yeah. You see, if you can see some bars, go back to the video, please. The last step, yeah. I want to, yeah, the last step. If you look at the screen, there's a solid bit that those look like papers and rags that have been filtered off from the water. So that is the use of the screen. Yeah, this is in a wastewater treatment plant. Water treatment plant will have, say, a river, and then where the flowing and going into the water treatment plant is free of these big solids. So the second physical method is sand filtration, which is a technique used to remove suspended solids from water. And this consists of multiple layers of sands of various sizes. When water flows through the sand filter, the suspended solids are trapped within the sand layers as residue, and the filtered water flows through. The next slide will show. Yeah, so this is a sample, I would say a simple method of sand filtration. You have your raw water at the top, and then you have sand, then gravel. The water that is going to be flowing at the bottom is kind of filtered water because as water flows through the sand, that is, gravel is sand as well. As water flows through it gets filtered. And like this is I would say this is a way in which groundwater gets to be filtered as it flows through the ground, such that wherever you go to abstract it, you find that it is somewhat clean physically. You won't see the dash. Yeah. Next slide. The next one is membrane filtration. In this technique, a membrane is used to sieve off particles and molecules. Several techniques can be applied here. So the first technique in membrane filtration is microfiltration. Yes, Mr. Ekole? So this is a video on microfiltration.
During microfiltration, water is forced through racks of vessels, with each vessel containing thousands of hollow fibres. The outer wall of each fibre is made up of tiny pores only 0.4 microns in size, or about 300 times smaller than the width of a human hair. The fibres filter out microscopic particles such as silt, protozoan cysts, bacteria, and even viruses. Microfiltration vessels are backwashed every 30 minutes to remove any build-up of particles on the membrane walls. The backwash water is returned to the pre-treatment tank for reprocessing. This helps the plant recover a higher amount of pure water.
So that was a short video on microfiltration. I'll go back to the on the slide above with the content, the previous slide. Yeah, so this microfiltration is one of the techniques in membrane filtration. And this kind of filtration filters off very fine particles to particle size in the range of 0.1 to 10 microns. It is able to remove suspended solids and bacteria, but does not remove dissolved contaminants. And as has been in the video that you've just seen, it involves a feed stream being introduced into the membrane under pressure. That is water being introduced through the membrane under pressure, and then in a controlled flow path. And the portion of the feed stream that passes through the membrane, that is the filtered water, is called the permeate, while the one that remains behind, that is the materials that do not pass through the membrane and which are ultimately flushed away, are referred to as concentrate. Yeah, so with microfiltration, you get water that is able to, you get water without suspended solids and without bacteria, but you still have water with dissolved contaminants. As you go further on, you're going to see that there are membrane filtration techniques that are able to filter off particles with very, very small size. So the next filtration technique. The second one is ultrafiltration. I think we had a video on that. Mistakenly, yeah. Oh, sorry about that. I muted by mistake. So I had been saying that with filtration, you're able to see that it filters off more particles, actually finer particles than microfiltration, which makes ultrafiltration a better water treatment technique as compared to microfiltration. It filters off particle sizes of 0.005 to 0.1 microns, and it is capable of removing salts, proteins, bacteria, and other impurities. So the next one is nanofiltration, which don't forget is another one of our membrane filtration techniques. And this one filters very fine particle size of 0.0001 to 0.005 microns, making it a better filtration technique than ultrafiltration. And it is capable of removing viruses, pesticides, and herbicides. The last one among the membrane filtration techniques is reverse osmosis. I think most of us are familiar with this one. and it is really okay. It's really expensive, but you find that it's used in maybe community treatment plants or something like that, and it's the finest available membrane separation technique, and it filters off very fine particles size up to 0.001 microns, and it is capable of removing metal ions and aqueous salts. Can you hear me?
Yes.
Any problem? I saw a hand.
Yeah, there's a hand raised up by Miss Alicia.
I hear you.
Okay, should I continue?
Yeah, we'll get
I saw a hand.
we'll get the questions after the class. But I know
Can hear you
right now. So please, you guys should wait for the questions. We have network issues. Thank you for your patience. Let's watch the video for reverse osmosis, I think.
Okay, let's watch the video for reverse osmosis.
Reverse osmosis works by forcing water through a special plastic membrane sheet to remove compounds such as salts, organic compounds, microorganisms, viruses and pharmaceuticals. Rolls of membrane sheets are wound into cylinder-shaped elements. There are several elements inside each long-pressure vessel. As water enters the vessel, it flows over the membrane surface as it moves from one end of the vessel to the other. The membrane layer is extremely thin. It allows water to pass through or permeate, while preventing other compounds from passing through. Membranes remove molecules based on their size, shape, and charge. Generally, contaminants larger than water molecules will not pass through, including most chemical contaminants and all microorganisms such as viruses and bacteria. Two streams of water are produced. Pure, clean water or permeate flows across the membrane sheets and passes through the membrane layers to the inside core tube. Water that does not permeate becomes more highly concentrated with salts and other substances. This water is called concentrate. The pure permeate water flows out the core tube and one end of the pressure vessel, and the concentrate water flows out another outlet. The concentrate water can then flow into other pressure vessels for the same process to happen again, so even more pure permeate water can be recovered. About 82% of all the source of water becomes purified water.
So that's it on reverse osmosis. As I said before, this is like the most commonly used, and as it is really I'd say really efficient. It removes most particles. The third one, the fourth physical technique is the cartridge filtration. Yeah. So cartridge filtration units, they consist of fibers that are capable of contamination levels less than 100 parts per million, that is milligrams per liter, which again, as you can see, is not as efficient as compared to the membrane filtration techniques. The fifth among the physical methods is the ceramic filtration. And ceramic filtration are quite different. Most of them are suitable for use in small-scale water filters, and it consists of a pot with small pores that can filter off dust and bacteria out of water. Again, which is not as efficient to use as the membrane filtration techniques. So that's it with the physical techniques. We'll move on to the chemical techniques in water treatment. Oh yeah, we had a video on ceramic filtration, sorry. Yeah, so that was a video on ceramic filtration. And that's it with the physical techniques. Moving on to the chemical techniques in water treatment. Mr. Ekole? Okay, thank you. So with chemical methods, chemicals are added in the water to be treated in order to render it palatable or safe for palatable, that is safe for drinking, or in order to render it safe for disposal to the environment. Different chemical methods include the following. Let's start off with chemical addition. Next slide, please. So chemical addition. With chemical addition, this can be done in two ways. Chelating agents are added to water to prevent negative effects of hardness caused by calcium and magnesium ions. These are just substances that are added into water to soften it. That is, you have hard water, you add some agents into chelating agents into the water in order to make it softer. And we can also have oxidizing agents which are added to neutralize with reducing agents. You add them into water in order to make it safe for drinking. And then technique in the chemical, among the chemical techniques is the next slide. Coagulation flocculation method. So this is used in, I don't know about other countries, but in my country, this is used in the water treatment plants, that is the municipal water. And so this is used to reduce suspended solids in water. And then, so you have coagulants that are added in order to reduce the charge of suspended particles, which aggregate into larger particles that are called flocks. And these flocks can be able to settle down by gravity, such that you have so that you can have the water that passes, that is free from the so that you can have water that is free from the pollutants. You add basically adding chemicals that is coagulants into the water. Then the chemicals mix with the pollutants, maybe, or the contaminants in the water, and then they form large particles that are called flocks, which naturally settle to the bottom by gravity. And then you have water that is free from these contaminants that can pass on to the next treatment process, which is, say, addition of chlorine. So the ionization and softening. So this one is done through an ion exchange, which treats water by absorbing certain cations and anions and replacing them with counter ions. It's basically just softening water, or adding chemicals into water that can has a known chemical substance has a known contaminant, and then when you add these substances, they're able to chemically react such that they're able to cancel out the effects that they have on each other. So the first one will have Mr. Ekole, disinfection. We have three techniques in this. We have boiling, we have use of UV radiation, that is the sun. Or you can have the sun, and you can also have UV radiation. And then we have chlorination. So boiling, I think we mostly use, or maybe we used to use this before we got to know about chlorination. Simply just boiling your water. The water that you use at home, can make it safe in a way. Yes. So boiling, this is most commonly used in small-scale household water treatment. And the next one is use of UV radiation. So if this is like UV radiation, say in the lab, it can kill microorganisms. That is in water treatment plants. And in treatment plants, we know that say it's a municipal where we have ponds with the waste. get the sun that is able to kill microorganisms that are otherwise hard to manage in the previous steps in the wastewater treatment process. And then the last one, that is the third one, is chlorination, which is basically the addition of chlorine into water, which is able to kill microorganisms. And I think this is, at present, this is the most commonly used treatment method. I think it, not really, I think it is used as the final step in my country's municipal water treatment process. So at the end point, they get to add chlorine to the water, which is then distributed to the end users. They add just enough chlorine such that by the time it is reaching the farthest user, that is at the very, very end, it is still able to treat their water as much as so even though it has been, I mean, okay, there's the concept of chlorine demand, which is basically enough chlorine such that it is able to the water even at the pipe, and also such that by the time it reaches the end user, it is still safe for drinking because it had enough chlorine. That is just putting in the required amount of chlorine and extra chlorine. That is the chlorine demand and just extra chlorine, which is able to treat water as it passes through the pipes and to the end user. So that's it with my presentation. I will be taking questions now.
Yeah, thank you, Madam Bikuru. So we are open up for questions. If you have a question, please put up your hand. You can send to the chat. I'll read the questions. Great.
Any question, any clarification?
We have some questions or any doubt during the presentation. It might be maybe due to network.
Hello, can you all hear me? Hello.
Yeah, we can get you.
Yeah. Hello, everyone. Hope you all are good. So there is my question. Like, it's not big a question. Just I need a clarification. That was really a wonderful presentation, and I get that all points. I want to know, like, you just told us about all types of filtration. Okay, so I want to know what we have to remember this all filtration, like the self sand filtration, then a membrane filtration, and that all filtrations. Then means you told us very types of filtration and what we have to remember this all uh, for our certification and for that knowledge too. Am I right?
Madam Bikuru.
I didn't quite get it.
We have questions. So please send your questions to the chat and we'll be able to understand.
Okay, okay, sure.
Yeah, we have network issues with let's check the chats. Okay, the question here I can see a question about what is the most effective method for treating spring or well water found in a place surrounded with peat latrines? I think you can get me, Madam Bikuru. So what is the most effective method for treating spring or well water found in places surrounded with peat latrines?
Well, I'd say first off, we shouldn't be drinking water from wells surrounded by peat latrines because there's possible groundwater contamination.
So,
but yeah.
So
But chlorination can do it, not
he's
as
asking
effective.
the most
Okay,
effective
chlorine is
treatment.
said, yeah. So chlorination can do it. Okay, I mean, if it's a small scale system, because it's a well, chlorination. I'd say
Okay.
chlorination because it's the most effective and inexpensive method when it comes to small scale water treatment. Yeah.
Okay, so
And then you probably need to take your water for testing in order to identify what contaminants are present, because chlorination can't deal with fluoride. I feel like chlorination deals with the bacteria and things in that line, but it won't be able to deal with the chemical, more so the chemical constituents of the water. So if you want to get rid of E. coli and the bacterial microorganisms in the water, you can. Chlorination is a good treatment method, but don't drink water from wells surrounded by pit latrines, I'd say.
okay, thank you. So we have here someone say, talk about rainwater treatment because most people take it safe. Safe yet at times it contains fecal matter. So they want you to talk about a little bit about rainwater treatment because some people drink it in some part of Africa. And
So rainwater is the purest form of water, I'd say. If it's water coming from the atmosphere, so I don't know why it would contain fecal matter, but it's the purest form of water. With fecal matter comes the risk of E. coli and things in that line. So again, chlorination. But even with chlorination, you'll need to know the amount of chlorine you're using. I am wondering why rainwater would contain fecal matter though.
Great. So I think the questions will be good. We have another question here. Someone says, please kindly elaborate on cartridge filtration because I'm hearing it for the first time. Thank you.
So cartridge filtration units, you know, I don't know if asking me whether you know what cartridges, asking whether you know what cartridges are is a good thing. But what would I say? You know of printers and the dust. Okay, in our printer, we have the carbon whatever the dust that is poured into the thing that. Okay, can you take us to the video?
So 1 minute.
Because just like all these, yeah, it's just fibers through which water flows through.
There is microfiltration. There's no video on cartridge, but I think this is just what we have. So there's no video unless we talk about
We
the
don't. Okay.
ultrafiltration, microfiltration, more or less.
Yeah. Yeah. We didn't have a video on. So, but cartridge filtration. I'd say it's basically a cylindrical tube. And inside we have fibers. Through which water flows, and the fibers they have pore spaces, which means they don't allow particles of certain sizes to pass through. Yeah. And the particle sizes which I mentioned was that is 100 parts per million. That is the particles that are like bigger than that can't pass through. Yeah, it's just a filtration technique as well.
I think it's a great question we have here. I think we have another question. It says, how effective is boiling? Take an example of organism that form cyst as protective mechanism. Because I think this question is like for boiling purpose, like how effective is boiling? Take an example of organisms that form cyst as protective mechanism.
Which question is that from?
Yeah, the question
from
is
Evaristo?
no, it's on is it Ocho, but this is just a question about it. So I can answer this question for you, as you know. So the issue about organisms, microorganisms, you have to define your question properly. Microorganisms that cause cyst. We know often we saw in the video, and I was trying to be able to make sure that you guys pay attention to the video where we had the ceramic filtration system, whereby we saw that we saw different kinds of contaminants in water, like we explained. The video and also the training which I gave some summary about it. So we saw about the particular resistant microorganisms, which causes scriptoporandiasis, which is called scriptoporandum. And this organism actually is part of the main organisms that form cyst. And normally it's difficult to eliminate this through treatment system like filtration, and as you know. So using the aspect of what you're saying about boiling at some point is highly efficient. And so if you are using chlorination or filtration system, this particular organism has resistance, which means it's difficult to be eliminated by filtration or chlorination. I explained that during that session we had. So boiling is one of the most effective way, but you know that boiling also have another effect in water. If you boil the water and you know, it loses its savour, you know, its elements which are making it feel like you're drinking proper water. You know, at the end of the day, the water becomes, you know, not really sharp in taste. I can say that. So that is the most important thing you have to know. So boiling is good. Okay, let me see. There are some questions here. I see another question. So how do I determine the cartridge size that can filter water like 750 liters per hour? This is a question.
Pardon?
But how do I determine the cartridge size that can filter water like 750 liters per hour?
Well, when you go to purchase these cartridges, these filters, they're usually labeled. The cartridges are labeled.
So let me see. I think some person's hands is up. Is it Magemeso Williams? Mr. Williams, at least you can say something. I think your hand has been up. I don't know if you put your question on the chat, but I don't know if your question has been answered.
Yeah. Good evening.
Yeah, evening.
Hello. Now, my question is if she can take us through the dosing and dosage of different chemicals, because some of us we have challenges like how much chlorine can I add into water, like and even the testing part of it, if possible, and if possible, if you can share us with the document which we can read and have the clear information about that. Thank you.
Okay, thank you. So, Madam Bekuro, you can your question.
Yeah. So I'd say the amount of chlorine you add in your water is dependent on the amount of contamination in your water. But basically, here in Kenya, they recommend you with the way our chlorine is packaged, the one that is used to treat water, it's called the water guard. They recommend using 1 cup. It's a small cup for around 10 liters of water. But basically, the amount of chlorine you add in your water is dependent on the contamination levels of your water, which is why in water treatment plants, they check on the contamination levels, and then they do experiments to determine the chlorine demand of your water. That is the amount of water, the amount of chlorine that your water demands, so that the chlorine can be just efficient enough to kill all bacteria in the water, and such that, and also they're also able to calculate free residual chlorine that can be added in the water that has already met with chlorine that has met the chlorine demand, such that this free residual chlorine can be used to treat, say, the pipes as it with the water as it flows through. So still, again, the amount of chlorine you add in your water is dependent on the contamination levels of your water. So you need to know the contamination levels of your water first. Yeah.
Okay, good question. Let's get this one question, and any other further question, please send it to the group chat. Madam, because she is there in the group chat on WhatsApp. We have you can send your questions in the chat, and you can get more precise questions about it. And let's just take one more question. No. Yeah, I see Mr. Paul. Please, you can speak, Mr. Paul.
Okay. Okay. Can you hear me?
Yeah, we can get you, Mr. Paul.
Okay. Good evening.
Yeah, good evening.
My question is, I was doing some little research about these water filtration methods, and came across a biological method of treating water, and that was using trickling filters. And it was saying that there are some bacteria that are used to destroy the Shigella, E. coli, and basically those pathogens in water. Can you give me the examples of those bacteria that are used with trickling filters? Trickling filters. That's my question.
So trickling filters is one of the steps in wastewater treatment. So you have water flowing through a medium, say rocks. Okay, in Kenya, the trickling filters are made up of rocks. That is, you have to have porous materials. But in other countries, I think the modernized countries that use modernized systems, they use plastics and some use fiberglass. So it's basically just the wastewater flowing through the porous material. So in this case, is rocks, because I'm using the example in Kenya. So you have wastewater flowing through rocks, and as it flows through the rocks, because it's a porous medium, you can have a waste that sticks on the surface of the rocks. And I mean, this is water that is from the toilets, and the toilet you poop and everything. So there's the bacteria, the gut bacteria that is available in the water. So, and also there's the waste in the water that is food for the bacteria that is also in the water. So as water flows through the porous medium, you get the bacteria feeding on the waste. So it's basically just a water treatment process. So such that the bacteria are literally feeding on the waste, moving waste from the water. That's why it's a biological water treatment process. But this is not really water for drinking, it's a wastewater. And that is like the third process. So the question was?
I see. So I think you got the question. Probably, I don't know if Mr. Paul is aware about the answers.
Okay, the question was the examples of those bacteria used in trickling filters to treat wastewater.
Oh.
Can you give me any? Yeah.
Well, I wouldn't lie and say that I know, but I know this is bacteria that is already in the water, that feeds on the waste in the water. That is gut bacteria from your body.
Okay.
This is what feeds on the waste that is already in the water. You have bacteria in your body that is in your gut. So as you pass on your stool or waste or whatever, this is the bacteria that ends up feeding on the waste that is in the water.
Okay, now I get you.
Yeah, but we can search that. You can.
Okay.
I don't know if we have bacteria that are introduced in trickling filters. I just know that it's bacteria that is already in our guts that eats up the waste in the water. Yeah.
We have a hand from Mr. Gibson. Hello, Mr. Jefferson. Hello. You can ask a question.
Yeah, good evening. Thank you very much. Mine is not a question. Maybe to start with the sprinkling filters. Simply, it's like a support system for biomass. For example, you have not just a particular microorganism like the presenter is saying, but a biomass is like a group of microorganisms, bacteria, growing on a supporting medium where waste is sprayed through the supporting medium, like say the spores, but you have a huge mass of microorganisms growing on that supporting medium. So that way it offers a large surface area for the waste to be fed on by the microorganisms. So as they feed on, they stabilize the waste in the waste stream flowing over the supporting medium, on which of course microorganisms are growing. But if you want to go to be a little more specific, you can group them, like you have nitrogen nitrate reducing bacteria, sulfate reducing bacteria, different kinds of bacteria you have growing there. So by the time the waste leaves the trickling filters, it will have been stabilized. By stabilizing, we mean all the nutrients and the waste in the waste stream has already been fed on by the microorganisms. These are single-celled microorganisms, just like us. They feed whatever they take in comes out as other products. Like you have hydrogen sulfide as a byproduct coming out as smell and so on. So the waste that leaves the trickling filters is what we call treated waste. With that must be conformed to, of course, environmental standards of that particular country as set by the environmental authority. So that's about the comment. That's the comment I wanted to make about trickling filters. And now let's look at chlorination. You know, like she rightly said, that chlorination depends on the level of contamination in the water. But this water, we are looking at the demand. First of all, the demand of the water for the chlorine. How much chlorine do you add? Of course, you do it experimentally, because you know chlorine you don't just add anyhow. And the WHO says by the time it reaches the tap, the final consumer should be between 0.2 and 0.5. There's a reason for that. Chlorine, when you add in excess, and the water has high organics after filtration, it still has some organics, you have what they call chlorine byproducts. And we have had cases of THMs being found in the water, and THMs have been implicated in cancer cases. They have the potential to cause cancer. So addition of chlorine in water is highly controlled, and it's done by people who understand how much to determine, not only chlorine, for all chemicals used in water treatment. You have to do an experiment that will inform you on how much you dose. Even for the coagulants, you do what they call jar tests, then you determine how much of the chemical you add in order to be able to treat the water to the national standard or WHO standard. So at community level, where you have a spring or a well, I think I would only say that it's better you go for things like water guard, because water guard is specifically formulated. They know how much you have to add in how much water. So it is formulated, like she was saying, in a certain amount of in a number of jerrycans, you add just this much. So it is, for it is the quality is already known.
Okay.
So that's something I wanted to say.
Okay, thank you very much, Mr. Jefferson. Thank you for explanative description and for the answers which you've given to the guy and elaborating on the question or the answers as the trainer rightly said. So I don't know, Mr. Alicia, that's one more question and then we are closing today. Any other further question, please?
Okay. Thank you for this great opportunity. And I'm very much sorry for joining you or the team late, or rather. Yeah. As it is stipulated in the SDGs, like SDGs number 6, it talks about clean water, making sure that clean water and sanitation for all. That is all about the SDG number 6, which was stipulated by the United Nations in the respect to CDC and WHO. So all these methods, I think you were learning over them to know how we can treat water in respect to the same SDG number 6 and the other. And I just wanted to walk the team through a very important question that someone asked about. Maybe there's water there, which the important method and the effective method to treat water, maybe that is rather mixed with the latrine, some kind of, because it is very important. That's why these days, or even not, let me not even put to say these days, no, we have all those environmental related regulations. Before even digging a bore, you must first call those experts to come and assess the environment. Which type of environment are you putting in your bore? So it is very much important, so as at the end of the day you are not victimized. So over the same, because you cannot again you start looking into the measures. You have this water which is not clean, which is maybe connected to a septic tank or so on and so forth. Then you start looking for other measures to treat water. So please, my concern is over this, and I'm emphasizing over the same point to say, before you be connected to any type of water source, it might be the tap water or what, you must first assess where your pipe or where your borehole is going to be put. It's very much important, so as to save lives. Not again you start looking for measures to treat water. No. So that is not the way it's supposed to be. I think this is what I was and I can also erude what the other mister is from talking about. Is very much important. Yeah, very much important. So following.
Yeah. So the issue is that we have less time and we need to find a way to please ask questions, or maybe on the group. Some people are having late nights now. I think in India it's late. So please, the session was made to be able to answer questions directly. You ask questions. If you have other contributions, you can give in the group chat, which is very important as well. We thank everyone, and seriously, we have been more than the time. It's more than 1 hour now. Thank you, Mr. Alicia, for that explicit history and good work. So please, we have to make sure that all of you guys will keep on communicating the chat, and then we have a training also on the 25th. But you guys will have a field work which starts from the 15th and upward till the end of the month, which means that we need to see what you have done. But you receive follow-up emails from the 15th, and you need to send us your own plan of work before the 15th or that, because we're going to send emails to today, 14th, and before the 15th, please reply to our emails on your plan, which analysis you're going to be taking, and let's stick to the plan before we are sending you the proper mail for the application. So mails will be sent today or tomorrow, 14th. So that is the most important thing. So send us your plan, which analysis you can do from the video and from the training we have about the application and what our analysis. Then we can be able to now send you the chat for you to be able to download the application, and then you start your field work, and then you submit your information. Thank you very much, and thank you all for coming. Madam Beku, do you have anything again to say?
If you have any questions regarding my presentation, when you ask that in the group, don't forget to tag me so that I can be able to see it. Thank you all for coming to the presentation. I had a good time. I hope you did as well. Have a lovely night. Happy Diwali to everybody that's celebrating that.
Okay.
Yeah, thank you so much. Thank you so much, dear. Thank you so much.
Okay. Bye-bye. Thank you all.
Thank you.